Bismillahirrahmanirrahim. Today our topic of discussion is delocalized chemical bonding. First of all, I will discuss what is localized chemical bonding with respect to organic molecules, and then I will discuss delocalized chemical bonding and its different types. At the end, we will discuss that how this is analyzed and which technique is used to analyze delocalized and localized chemical bonding. So, coming to our discussion, first of all, localized chemical bonding. Localized chemical bonding or localized chemical bond is one in which the electron pair it is shared between two nuclei. ये restricted होता है, इसकी movement भी नहीं होती और ये दो atoms या दो nuclei के दरमियान localized होता है या इसकी position restricted होती है, movement नहीं होती. इसीलिए हम इसे localized chemical bonding कहते हैं. अब अगर हम इस मॉलिक्यूल को देखें जिसका नाम है CH3Cl, sorry this is CH3Cl and this is known as here this carbon and chlorine has localized bond, here this carbon and hydrogen has localized bond, so it is not movable. In second example, you can say that electron pair between this carbon and hydrogen in methane, it is also localized, and even this pi bond is also localized. Although it is pi bond, C double bond O, but it is also localized. It cannot change its position. Now, delocalized chemical bond. A delocalized chemical bond is defined as though that chemical bond in which the nuclei, the shared pair of electron is shared by, the electron pair is shared by more than two nuclei. The example is 1,3-butadiene. This is 1,2,3,1,3-butadiene. Here this double bond is in conjugation with this double bond. So you can say that this double bond move over here and you can draw canonical form like this because this can move again, and you can also draw various types of canonical forms for 1,3-butadiene. Remember students, delocalized chemical bond can be of three types. As you know that it is the electron pair which is shared by more than two nuclei. So this sharing is due to the conjugation between double or triple bond. If there are two double bonds or two triple bonds or one double and one triple bond in conjugation with each other, what does it mean? It means there is only one single bond at alternate position. So that is why this electron pair is shared between more than two nuclei rather than only two nuclei. Similarly, the second type of delocalized chemical bond is that in which the electron pair is in conjugation with the p orbital. For example, if you see over here, this is an example of vinyl chloride. This is an example of conjugation or delocalized chemical bond in which there is delocalization between double bond and p orbital electrons. The electrons in the p orbital, like chlorine, these are in conjugation with each other. So that is why you can draw two canonical forms for vinyl chloride. Similarly, you can draw canonical forms for this carbonate anion. So this is also delocalized and chemical bond carbonate ion. Similarly, vinyl anion. So carbanion, this type of carbanion can also be observed, and it shows that the electron pair is shared between these three carbons. So that is why you can say that this is a delocalized chemical bond in which there is p orbital which has this electron pair. It is in conjugation with a p or with a double bond. So here are some examples like if cation is there, then it is the electron pair is also shared by the cation because it has p orbital, so it is in conjugation. Similarly, if it is radical, free radical, it can also be an example in which the double bond is in conjugation with the p orbital. And if it is carbonyl, it is also discussed as earlier. The third type of delocalized chemical bond is that in which there is cross conjugation. For example, benzophenone. This is the structure of benzophenone. So you can say that in benzophenone, this double bond is in conjugation with this one from one side, and it is also in conjugation with this side from another side. So you can say that the three groups are present, two of which are not conjugated with each other. Two phenyl, they are not conjugated with each other, but they are conjugated individually with the keto group. So this is also a type of delocalized chemical bond. Similarly, here you can say this type of ether in which there are two double bonds around oxygen. So this double bond is in conjugation with the electron pair on oxygen on one side, and it is also in conjugation with the electron pair of oxygen with this double bond. So this is an example of cross conjugation. So it is also an example of cross conjugation. You can draw various canonical forms which can show that there are two groups which are in conjugation with the third one, but they are not conjugated with each other. The last type of delocalized chemical bond is in hyperconjugation. Hyperconjugation is a phenomenon which shows that there is delocalization of sigma electrons. So it can be explained that it is a stabilizing interaction that results from the interaction of the electron in a sigma bond. So this sigma bond is in conjugation. For example, in this case, this is CH3, this is p orbital carbocation, in which positive charge is over here. Mm, then this hydrogen, one of the hydrogen, it donates its electron pair to this one. It can be explained like this. This electron pair, carbon hydrogen bond, which has actually electron pair, it is moved over here. And here you will see that this electron pair is delocalized between these hydrogen, carbon, and carbon. So that is why it is also a type of delocalized chemical bond. But here the delocalization is in sigma bond, not in pi bond. So what are the difference? There's a prominent difference between a delocalized and localized chemical bond. A localized chemical bond is that in which the electron pair are shared by only two nuclei. नॉर्मल सिग्मा बॉन्ड भी हो सकता है, पॉय बॉन्ड भी हो सकता है, तो कार्बन कार्बन डबल बॉन्ड बिल्कुल आइसोलेटेड कार्बन कार्बन डबल बॉन्ड भी हो सकता है। जबकि केमिकल बॉन्ड जो जिसमें दो डबल बॉन्ड एक दूसरे के साथ कंजुगेशन में हो या फिर वो पी ऑर्बिटल के साथ कंजुगेशन में हो और उस तरह डबल बॉन्ड जो है वो इलेक्ट्रॉन पेयर जो है वो डीलोकलाइज्ड हो और दो से ज्यादा न्यूक्लियाई पे, तो उसे हम डीलोकलाइज्ड केमिकल बॉन्ड कहेंगे। यहाँ पे लोकलाइज्ड केमिकल बॉन्ड में इलेक्ट्रॉन की पोजीशन लिमिटेड होती है, जबकि इलेक्ट्रॉन की पोजीशन डीलोकलाइज्ड केमिकल बॉन्ड में लिमिटेड नहीं होती, बल्कि ये थ्रू आउट मूव करते रहते हैं। इसीलिए आप इनकी कैनोनिकल फॉर्म्स ड्रॉ कर सकते हैं। इस किस्म का लोकलाइज्ड केमिकल बॉन्ड हमेशा हमेशा फ्रंटल ओवरलैपिंग से मॉलिक्यूलर ऑर्बिटल के आपस में ओवरलैपिंग से बनता है, जबकि फ्रंटल ओवरलैप यानी फ्रंटल ओवरलैपिंग से ये बनता है, जबकि साइड वाइज ओवरलैप से डीलोकलाइज्ड केमिकल बॉन्ड बनता है। आज का टॉपिक हमारा हम डीलोकलाइज्ड और लोकलाइज्ड केमिकल बॉन्ड के बारे में था और हमने उसे डिस्कस किया है। अब हम जो है वो डिस्कस करेंगे कि किस तरह हम डीलोकलाइज्ड और लोकलाइज्ड बॉन्ड को एनालाइज कर सकते हैं। जैसे कि आप देख सकते हैं कार्बन कार्बन डबल बॉन्ड ये एक लोकलाइज्ड केमिकल बॉन्ड है। इथीन के मॉलिक्यूल का यूवी स्पेक्ट्रम ये शो करता है कि ये 200 से बिलो नैनोमीटर पे एब्जॉर्ब कर रहा है, तकरीबन 150 नैनोमीटर पे। जबकि आप इधर देखें तो ये कार्बन कार्बन डबल बॉन्ड कंजुगेशन में है और यानी एक दूसरे के साथ शेयरिंग हो रही है। इस 4 एटम्स के ऊपर ये इलेक्ट्रॉन पेयर जो है वो डीलोकलाइज्ड है। तो ये डीलोकलाइज्ड केमिकल बॉन्ड में ये जिसकी वजह से ये यूवी स्पेक्ट्रम में आपको पीक मिलती है 217 नैनोमीटर पे, यानी 200 से अबव। तो इसका मतलब ये है कि आप यूवी स्पेक्ट्रल एनालिसिस से लोकलाइज्ड और डीलोकलाइज्ड केमिकल बॉन्ड को डिफरेंशिएट कर सकते हैं। सेकेंड एग्जाम्पल अगर आप इसमें देखें तो ये है डीलोकलाइज्ड केमिकल बॉन्ड मेसिटाइल ऑक्साइड में। यहाँ आप देख सकते हैं कि लेमडा मैक्स 228 नैनोमीटर पे है, जबकि ये एक लोकलाइज्ड कार्बन ऑक्सीजन डबल बॉन्ड है जो कि एब्जॉर्ब करता है बिलो 200 नैनोमीटर। सेम इज द केस विद कार्बन कार्बन डबल बॉन्ड। So this is the end of the lecture.